Today we're going to continue talking about piecewise functions, but instead of graphing the function, we're going to write the function. In other words, it's going to be backwards. You're going to have the graph, and you're going to create the equations that get the piecewise function. Students will often say that this is easier than what we did first, but I think that's just because you're starting to catch on. The truth is, whether you're writing or graphing, the concepts are very similar, and we're going to get this. So, if you had been in class, I truly would have just asked you to tell me anything and everything that you find true about any of these pieces. Looks like we have a diagonal line and we have a horizontal line. Make sure that you can see both of those. So anything and everything that you think is true. Now, a very common response would be for students to talk about the slope. It definitely rises up 3 and runs 2. Whether you look at the 2 points I just picked right there, the slope is 3 over 2. Now be careful, it's not negative, as the graph truly is going up 3 and over 2. What's something else that's true? Yes, there's a point here. It's the point 1, 3. Maybe more specifically, you feel like you're going to the left of that point. Yes, you're going to the left of the x value, which is -1. Again, notice that I'm using the x value from my endpoint to describe this left-hand movement. What else is true? That's right, we need a y-intercept. Now, if you extend the line backwards, you can see that the y-intercept seems to be somewhere in this vicinity, perhaps maybe at 4.5. If you recall from your algebra classes, you can be sure that the y-intercept's 1.5 when you solve for b. Now remember how to solve for b? You start with the equation y equals mx plus b. You plug 3, that is this 3 right here, in for y. We got our slope already. You plug x, -1, in for x, and you solve for b. So what we're showing here is the old strategy where you basically plug in a point and you solve for your unknown. So this comes out to be, well, what? It comes out to be 3 equals -3/2 plus b. And if you add 3/2 to both sides, that's like adding 1.5, and that gives you 4.5. So we also have a y-intercept, b equals 4.5. Now, do you realize what's happening here? We now have enough information to write the equation for our first piece. That's right, it's going to be mx, 3/2 x, plus 4.5, but it's only for x values, comma, x values less than -1. And we have our first piece written. So how about our other piece down here? What are some things that are true about this piece? Sometimes students would tell me that the slope is 0. Sometimes kids would comment on the y-intercept being at -1, b equals -1. To be specific, the equation is y equals -1 because it's just a horizontal line. Now this point right here is pretty important. It's the point -1, -1. But it's the x value that we're really concerned about because the graph goes to the right. The graph goes to the right of that x value. And how do we say going to the right? That's correct. Greater than that x value. And so once again, we have the information that's needed to describe this piece. We just need the equation. Now remember, the equation's a horizontal line. That's why it's just -1. And then we need the idea that it's going to the right. So that's greater than my starting point, greater than -1. When you're writing a piecewise function, you want to focus on one piece at a time. You're going to determine the x interval. In other words, you're going to think about the starting point or the end point for that piece. And you always want to write the equation also Typically, when you write the equation, it's either going to be a horizontal line of the form y equals c, or a diagonal line of the form y equals mx plus b. Let's try another one. There's definitely the two pieces in this problem. You want to focus on this one right here first. It doesn't matter. Now, when you focus on this piece, you might deduce that the slope is 1. You may notice that the starting point or end point, whatever you want to call it, is at x equals 0. Now, x equals 0, since my graph is going to the left of that point, I'll choose a less than sign. Now, sometimes people aren't sure, should it be equal to or not equal to? Well, the truth is, it's either going to be equal to for one piece or for the other. So I'm going to go ahead with the equal to for this piece. And I almost forgot, we also need the y-intercept, but the y-intercept is also 0. So we have y equals mx, that is y equals 1x plus 0 for x's that are less than or equal to 0. Again, the less than sign right here is because the graph is going to the left. Do I need the 0 here? I do not. I'll leave it there, though, since I already wrote it. How about this piece right here? This piece, it has a slope of up 2 over 1. It has a slope of 2. It has a y-intercept. It has a y-intercept right here of 0, so the same y-intercept. And the only other thing we need to realize is that it's going to the right. Since it's going to the right, I'm going to choose a greater than sign. Greater than 0. Again, that's the starting point. So I'll write my equation as y equals mx, y equals 2x, plus 0 if I prefer, for x's that are greater than 0. Again, greater than because it's going to the right. At this point, some students will be ready. Are you ready? Are you going to try to come up with the equations for this graph? Be careful because it looks like the scale, or each unit on the scale, goes by 2's. See if you can write equations for this piecewise graph. Now, if you have not paused the video yet, you want to pause it, because in a moment I'm going to go over the answer. All right, so piece number one, this guy right here. Do you see the slope is 3? Have you maybe noticed this point right here as -1, 4? Oops, -2, 4, because it goes by 2's. Now, the y-intercept would be what happens when you extend the graph further up, but instead of guessing what that would be, what we can do is a little bit of math on the side here, right? Where you can plug in the point. You can plug in the point, -2, 4, as well as plugging in the slope, but ultimately solving for b. So it turns out that we're going to get 12 here, and hold on a second. Oh, darn it, I plugged these in backwards. Okay, careful. Let me make sure I'm clear about what we're doing here. We're plugging in the point -2, 4. So we want to plug 4 in for y, but we want to plug -2 in for x. Okay, yeah, now when you add 6 to both sides, you're going to get b equals 10. So we have our y-intercept, we have our slope. The only thing we want to conclude is that the graph is going to the left, and its starting point would be the x value of -2. So we're going to write our y equals mx plus b, 3x plus 10, and we are to the left we are to the left of -2. Next, we have like a horizontal line, and this horizontal line appears to basically have a y value of 4. We want to note that it is in between a couple x values. It looks like now we're at x equals 2, and that means that my restriction is going to be such that I'm between the x values of -2 and 2. Now, here again, we have a question. Where should we put the equal sign? Well, it actually doesn't matter since the graphs connect. You just have to put the equal sign somewhere. I'm going to choose put the equal signs with my horizontal line, but the truth is you could have put it with your first diagonal line if you wanted to. You just can't put it on both. Let's talk about this last diagonal line. Whoops, this last diagonal line here. Now, this one actually has a negative slope for a few reasons, mainly because I go down, actually go down 6 and over 2, right? But the truth is I go down, so my slope is negative. -3 to be exact. I should be solving for the y-intercept. It may not shock you, though, that we have symmetry in this problem. So I am going to plug in the 0.24, but we're going to find out that we get the same y-intercept. Let's show that anyway. You plug in the 0.24. That means we're plugging 4 in for y. Remember, my slope is negative. I'm going to plug 2 in here for x. And bingo, you get the same y-intercept at 10. And we want to conclude that the graph is going to the right. The graph is going to the right of our starting point. Whoops. Sorry, it's the starting point, the x value of the starting point. So again, we say that we're going to be greater than that x value because, again, the graph is going to the right. Now, how does this all shake out? -3x because the slope's negative, and we're going to the right, so I use a greater than sign of the x value of 2. How about this one? Kind of look familiar, perhaps? Like a step function. When you have a step function like this, you just want to realize that each one of these steps, its equation is just a number. And the x values that are being used are, well, for the first step, are -5 to -4. But I have an open circle at -5 and a closed circle at -4. So it will be equal to -4. How about the next step? The next step's at 4, but we're going to be between -4 and -3. Of course, we're equal to -3 because it's closed. And each step just keeps going down here. As we continue, we can kind of keep following the same pattern as we go all the way to 1. And again, 1 is the height of this graph, so that's y equals 1, but it's between the x values of -1 and 0. So -1 is less than x is less than or equal to 0. Step function. All right, well, now it's your turn. Try to write some equations for these piecewise functions. Looks like I only gave you, actually, your paper looks a little bit different. You should see 3 graphs on your paper, and then at the bottom, 3 somewhat review type questions. So please take a look at all 6 of those problems as you keep working on writing piecewise functions.